Okay, so today we're going to continue with centroids and orthocenters. All right. Remember, we did our points of concurrency for the centroid by finding the median of each side. So keep in mind that by finding the median, you're actually finding that midpoint and then drawing a median, a line connecting the opposite angle to the midpoint of the opposite side. That gives you the median. It cuts this side in half. So the median from angle BAC is AE, and it cuts BE and CE into two congruent parts. It bisects it. Okay? And same thing happens from angle B and angle C. And so you have these medians that intersect at what we call the centroid there. Okay, the properties of the centroid. If I were to take AP, this length right here, maybe use a highlighter there. This length, thank you. That length right there is 2/3 of our entire length, AE. Okay, which means PE is what portion of the entire length? 1/3. Okay, and that's true for any of our medians. When it's cut off from the angle to the actual centroid, that is a length of 2/3 of the entire length of the median. And from the centroid to the side, that's a length of 1/3 of the entire median. Okay? So that's a property of a median. Remember, that's your center of gravity. That's where we're balancing that triangle there. All right. On the other one, if you turn the page there, on page 177, the other piece there was the orthocenter, and we did those constructions on that first day as well. And those constructions were where we found those altitudes, where the altitudes intersected. Okay? The lines containing AF, BD, and CE, those all meet at point G, which we call the orthocenter. Okay? All right. What do we know about perpendicular lines? Let me ask that a different way. What do you know about the slopes of perpendicular lines? They're inverse reciprocals. So, for instance, if my slope was y over x of one line, the slope of the other line would be negative x over y if it was perpendicular. All right. If we use numbers, if the slope is, say, 1/2, a slope that is perpendicular would be negative 2 over 1. Okay, so we're going to use that today as we go through and try to construct these. All right, so what I want you to do is just kind of reviewing some of those concepts. I want you to work on 1 through 3 on the bottom of that page with your groupies there. Okay, off you go. All right, let's check the first one out there. PN, okay, when we put them in there, actually take 2/3 of the length of QN, which is 33. Therefore, 2/3 of 33 is 22. So this length is 22, and then 1/3, the remaining length, would have to be 11 if the whole thing's 33. Okay, number 2, we have PN, 2/3 of QN, and if QN is 45, 2/3 of that is 30, so divide it by 3 and then multiply it by 2, and the 2 have to add up to 45, therefore the other part would have to be 15. QP would be 15. And then that last one, we have PN equals 26, and QP is 13. Okay, how many got them? Not too shabby. Okay. Any questions? All right, go ahead and turn the page. I want you to try numbers 4, 5, and 6 there. 4, 5, and, or excuse me, let's just go with 4 and 5 first. Then we'll get to 6. Okay, they've got it. Numbers 4 and 5. Okay, CE is 21. CD is 14. Okay, 1/3 of DE is 1/3 of CE. So if DE is 7, we got to triple that to get CE. And then the remaining, if DE is 7, then CD would have to be 14. So if they give us that 7, whole thing's 21, this part's 14. And the same process over here. CE is 36, therefore CD would be 24. Any questions? All right. We're going to do 2 more problems together. We're going to give number 6 a shot. If you take a look at number 6, I'd like you to go ahead and graph that out. Okay, we're going to do number 6 and number 9. Do this first one. I think I'm going to go ahead and put my coordinate plane, my axes right here. Okay, so we'll start with number 6. Let's go ahead and find the coordinates of the centroid. So first, I have to start by... Okay, can I please have your attention up here? So we have our three points. How do we find the median? Or excuse me, how do we find the centroid? I kind of gave that away. Sam? Good. Find the middle of each line and draw a line to the opposite angle. That gives you the median. So like on a horizontal or vertical line, it's pretty easy. That's a horizontal line. You just 1, 2, 3, 4, 5, 6. So 1, 2, 3. There's my median, or my midpoint there, and I draw. So there's my median. There's one of my medians. Okay, how do I find a midpoint on these other lines? Yeah, Drew? Yeah, you could use the slope. So like on this one, I go up 9 and over 3. So really, I'd have to go up 4.5 and over 1.5. So looks like it's about right there. Okay. The other process you could use to do that is you could use the midpoint formula. So like for A, it's at -2, -1, and B is 1/8. The midpoint, if I add up -2 and 1, my x values, -2 plus 1 is -1, and divide by 2 is -1/2, right? And then 8 plus -1? Seven divided by 2? 3.5. Okay, so if you're going to use decimals in one, you should use decimals in both, I guess. Okay. If I plot -1/2 and 3/2, so I'm here, and 1, 2, 3.5, that gives me there. It's a little easier, I think, to use the slope method, but that right there gives us the centroid. Coordinates are 1, 2. So that was one of those points where, like, dude, I asked a question, you guys answer the question. Okay? Because you can do it. All right. Any questions? All right, we are going to try number 9. And for number 9, I would suggest making your axes right here. And if you look at your coordinates, your coordinate has an 11 there. This has only 10. So I would probably use a scale that goes from 0 to 20. Maybe go up by intervals of 2 there. Okay. All right, so tell whether the orthocenter. How are you going to find the orthocenter? Yeah. Yeah, you could do that. It might be a little better when you have a grid to use to actually calculate the perpendicular bisector. Kind of a different route. Okay, so let's go ahead and graph it first, and then we'll go through it. Okay. So while you guys are doing it there, I'm going to put it up here. Hey, what type of triangle is that? Right triangle. What do we know about right triangles? They do have a 90-degree angle. What do we know about the orthocenter in a right triangle? It lies on it. Now, so we actually know the answer because we've studied that a bit. We know it lies on it. But if I'm finding the perpendicular bisector of each side, hey, this one's kind of easy. I mean, I find the bisector. It's a horizontal line. I go, looks like I have 1, 2, 3, and then 4 if you take this half and this half together. So I really need to go over 2, so that's 1 and 2. There's my bisector, and a line that's perpendicular just goes up through it like that. Okay, and this way is pretty easy too. That's 3, so I go up 1.5. This distance, take half of it. That's the bisector, and then a perpendicular line that goes across right there. A quick sketch, and so we could already see where the other one's going to be. However, if you had an acute triangle or an obtuse, you should also know the answers already as well. Outside or inside. When is it outside? When it's obtuse. And it's inside when it's acute. Okay? So there might be some notes to put there. But if you wanted to, you could get the other one by finding the slope of this line, the rise and run, and then doing the inverse reciprocal to get the slope of that last perpendicular bisector. Okay, but you shouldn't have to do that on here. Yeah?
Doesn't the orthocenter need to go to the vertices?
No, not the orthocenter. That's your orthocenter is your perpendicular, or I'm sorry, I did my perpendicular bisector, didn't I? We need to do the altitudes there. My goodness. Good job, Alex. So we got that one there and that one there. So here's our last altitude. Okay, and it looks like it's going to lie right there on that corner. Yeah, that's a good point. You need to find the altitude for the orthocenter. So I had the wrong right angle. But still lies on it, right?
So, wait, wouldn't it lie on...
It's going to lie right here.
Oh, okay.
Because this hits here, this hits here. And if it's obtuse, that altitude lies on the outside. Right? Okay? Okay, so make a note of that. Your assignment, let me get that out to you. If you want to try another one of those, you could try, I'd suggest trying number 10. I'll put up the answer. Or, excuse me, number 11. I'll put up the answer here in a minute. If you want to see that one. So... we'll go up by 2's again. we've got each of those. You could just slide your corner over using a corner of a piece of paper. That's a good way to find that altitude. Paper over there. Since this one's an acute triangle, you don't have to, or you should know that it would lie on the inside, but if you actually want to construct them, just using that right angle in the corner of a piece of paper would work out. And remember, the slopes would be inverse reciprocals. But they've got, it's like the coordinates of that one would be 9. Looks like 2. Got the altitude that time, not the perpendicular bisection. My goodness. Okay. All right, very good.